Hello guys, my name is Ankur Patel. I'm a tutor at REACH at the University of Louisville, and today we're going to be going over how to convert between different acid-base units such as pH scale and then molar concentrations. So a few quick equations that I'd like to put up on the board real quick that will help is that pH plus POH equals 14. And so all these conditions that we talk about are always at 25 degrees and other standard conditions. The pH scale actually does change around a little bit depending on temperature, but today we're going to be talking about just 25 degrees, just standard conditions. The next one is that pH equals negative log of the H plus concentration. And the H plus concentration has to be in molarity, which is moles of the solute per liter of solution. Next one is POH equals negative log of OH concentration, and then H plus concentration multiplied by OH concentration equals 1.0 times 10 to the negative 14. A couple things you can convert to do to this equation is put it in terms of the pH. So 10 to the negative pH value is actually equal to the H plus concentration. Same thing with this one. 10 to the negative POH will give you the concentration of OH. But that's just derived from these equations. All right, so let's say you were given an H plus concentration of 1.0 times 10 to the negative 4. And you were asked to find the pH, the POH, and the OH concentration. So basically everything else you could find from the H plus concentration. So let's find pH first. Do you see an equation here that you can convert H plus to a pH? And you're probably thinking this equation. So pH is found from the negative log of the H plus concentration. And so this is your H plus concentration. And this is molarity. And so if you crunch that in your calculator, you'll have a pH value that is equal to 4. So far you got the pH. Now you're still looking for POH, and you're still looking for OH concentration. So a couple ways you could do this. If you have a pH, you could plug the pH into this equation and then find the POH. So let's do that. So the pH is 4. We're using the first equation up there, plus the POH equals 14. So if you convert, if you move the 4 onto that side, subtract it from both sides, you will get that POH equals 10. All right. So you got to find one more thing. You're looking for the OH concentration. And so there's a few different ways to do it. I'll go over one now, and then I'll talk about the next one after. So if you have the OH concentration, or the POH, then you can plug it into this equation, which 10 to the negative POH is equal to the OH concentration. So let's do that. 10 to the negative POH, which is 10 in this case, equals the concentration of OH, right? So if you ever, when you do this, you'll find that the OH concentration is equal to 1.0 times 10 to the negative 10. And concentration are always in molarity. So there you go. So you see that we didn't have to use this equation, and we didn't have to use this equation, but we used this one, and this one in this case. There's times where it'll be easier to use certain equations, and just because it's easier to work with the numbers. It's much easier to say that pH plus POH is equal to 14 than have to do this, which is equal to a very, very small number. So another way you could have done this is if you had the OH concentration, you could have plugged the OH concentration into this equation and then find plug the H concentration into here and find the OH concentration. So then you would have this. And then to find the POH from that, you could have plugged the OH concentration into here and then got the POH. Still do the same thing to get the pH. Just plug the H plus concentration into here. Or you could, after you found the POH, plug it up into here, and you would also find the pH. So there's different ways to do it. Whatever you find easiest is probably the best way to go because they all work. I hope that helped. Thank you.